The regression line of x against y. The y on x regression line, which we've looked at, predicts y from x. It answers, if I know x, what is my best estimate of y? For example, if you know how many hours someone studied, x, you can predict their test score, y. And we talked about the limitations of this in the last lesson or two. As we have seen, the line is the result of minimizing the areas of squares based on vertical residuals. So like this, vertical residuals. And we saw this before. If we look at those residuals and we form a square out of them, and then we add up the sum of all of those areas, the idea is to minimize that area, and then we get the y on x regression line. Now instead we're talking about an x on y regression line. This predicts x from y. It answers, if I know y, what is my best estimate of x? So with y on x, we've got the x value and we use it to predict a y value. With this one, we're going to go in the other direction. The example, if you know someone's test score, y, you predict how many hours they probably studied, x. And we can see with this one that the residuals are horizontal, and these squares are formed using the horizontal residual as the length. But the process is still the same. We want to minimize the sum of that square. And remember, x on y means that we're making a prediction in this direction. We know the y, and we're predicting the x. Should note that they are not the same line unless the correlation is exactly positive or negative 1. The two lines have different slopes and intercepts because they minimize different sets of errors. Y on x, as we've seen, minimizes the vertical distances. X on y minimizes the horizontal distances. And so in general, they are different lines.